And hi everyone, this is Mohan, and this is a short video demo of my final project, a multi-period portfolio optimization tool built with dynamic programming and an interactive Streamlit interface. Well, the idea is simple. An investor can balance between a risky stock and a risk-free asset over time. And my model used dynamic programming to decide what stock weight to hold at each step, given the investor's risk aversion and the market region. Well, everything is wrapped in this Streamlit app. On the left, I have control for the market model and the dynamic programming settings and the backtest parameters. And on the right, I show explanation and all the plots generated by the engine. Well, here you can set the risk aversion gamma, the penalty on maximum drawdown, and transaction costs, both linear and quadratic. And there, and you can also choose the initial region, which is the bear and bull region parameters, and their drifts, volatilities, and the transaction matrix. And I also control the time horizon stepwise, so the step size and also the number of simulated paths used in the backtest. So the app is basically a front end on top of my DP engine, and also the region switching market simulator and the backtester. And when I run the model once, I keep the gamma as 3 and also a moderate MDD penalty. And then I click the run DPM backtest. And this is called this will call my DP engine to solve a high dimensional DP over wells allocation MBD and region, and then use the backtester to simulate performance of my price pass. And here's the main result for one representative pass. And the top panel compares the DP strategy wells in blue to the normalized stock price in gray, and optionally like a baseline strategy in light blue. You can see the DP strategy participates in up movements, but also like cut risk when the market drops. And the second panel shows the stock weight over time, and this is directly read from the DP policy table, and the baseline weight is overlaid so you can see how the optimal policy reacts differently. And the third panel checks maximum drawdown in red and the region pass in purple, and this ties back to the MDD penalty in the utility and the region switching market model. And the last panel is the number of shares held, which is useful to debug how the allocation translates into actual positions. And this two heat map shows the optimal next stock weight as a function of current wealth and allocation. For a fixed time and MDD level, the left is bear and the right is bull. You can see the DP recommends more conservative weights in bear and more aggressive weights in bull, even like with the same starting wealth. And the app also um support a multi-gamma analysis, and in the configure, I define list of risk aversion levels, and the app runs DP and backtest for each. And this plot still in running, and this plot will compare the wells pass, and this frontier style chart shows like the trade-off between the risk and final wells as gamma changes. Well, so overall this project, yes, let's see. And so overall, this project combines a region switching market simulator, a CRR and MDD aware dynamic programming engine, and a backtesting framework. And this Streamlit UI, so you can experiment with parameters and visually understand how the optimal strategy behaves. And thanks for watching.